Hello and welcome to this learning video. In the very beginning of this Z transform, we have discussed the application of Z transforms. Like it is used in analyzing the digital signals, it is used in designing digital filters, sharing of files, maybe JPG or MP4 or MP3 files. And here in this learning video, we are going to take the actual application of the Z transform as far as mathematics is concerned. So, Z transform is used in solving the difference equations. So, here in this learning video, we are going to take difference equation, and with the help of Z transform, we are going to get the solution of difference equation. Okay, so let us start with the method of solving, or in other words working rule for this solution of difference equation by Z transform. So let me write it as working rule. So working rule comprises of 4 steps that you have to follow in order to solve problems on this. So the very first steps So the very first step is write down the given difference equation. Write down the given difference equation. And the very next step, after you write down the given difference equation, you just have to take Z transform. Take Z transform on both sides. This is the second step. After you take the Z transform on both the sides, you may encounter some of the expression where you can apply the property, namely the shifting property. Use shifting property and apply the given conditions. And when you apply the shifting property, after that you have to apply the given condition that would be given to you in the problem. Once you do this, then you have to do some arrangement of the terms and take inverse Z transform, or you can write just take inverse Z transform. To get the required solution or required sequence, you can say. Sequence or sequences. Okay, so let me tell you the very methodology of this solution of difference equation by Z transform. You will be having here difference equation. Okay, you are having here the difference equation, and on this difference equation, what you have to do, you have to apply the Z transform. The moment you apply Z transform, this difference equation will get converted to algebraic equation. And you solve this algebraic equation and apply inverse Z transform. inverse Z transform, you will get required sequence or the solution. Okay, so this is what we are going to do here. Take difference equation, apply Z transform, you'll be getting algebraic equation. Solve algebraic equation, apply inverse Z transform to get the required sequence of functions. Okay, so this is going to be the scenario here of this topic. Okay, so if this is clear to you, I can take a result that we are going to make use of. Okay, so let me rub this now. So we'll write it as a remember, or as a note you can write. So the very first thing that you have to remember, we are writing it as a note, are the notations. Okay, so sometimes like you'll be having you may encounter things like Z transform of u of n. So we'll denote this as u of z, or sometimes Z transform of y of n, or y of something, so you can write it as y of z. Okay, etc. This one notation that you have to remember. The second thing is the shifting property. Okay, I hope you understood the shifting property that we have taken earlier in the earlier classes. So let us see this shifting property first. So what is shifting property? Z transform of f of n plus k is equal to z to the power k is equal to z to the power k into f of z minus summation I is equal to 0 to k minus 1 f of I into z power minus I. Okay, f of I minus z power minus I. Okay, so if you want, you can expand this, because we have written like this, but here in when you solve the problems, we'll be making use of the expansion. So it is like when you take the expansion, so it is like z power k f of z minus, put I is equal to 0, so this would be f of 0, z to the power 0 is 1, then it should be minus, put I is equal to 1, so this would be f of 1 or f1, z power minus 1, so I can write f1 by z, likewise f2 by z square minus f3 by z cube, and so on. So I'm going to make use of this result. Okay, and don't bother about this f0, f1, f2 and so on. I can write f0 like this, I can write f0 like this. These are just the notations, and all these values f0, f1 would be given to you. Okay, so I think we can take a problem on this to start with. Okay, so let me take a simple problem. I think I should remove all this thing so that it would be better to example 1, solve yn plus 2, solve yn plus 2 plus yn is equal to 2. So this is the difference equation given to you, and some conditions also given. Y of 0 is same as y of 1 is equal to 0. Now we have this problem and we have to get the solution of this problem. So how one can start with? Just follow the steps of the working rule, right? So what is the very first step of this working rule? So the very first step of this working rule is write down the given equation. So I can write the given equation is, what is it? Yn plus 2 plus yn is equal to 2. Okay, now just take the Z transform. Taking Z transform, on both sides, we get, so what we will be getting? We will get Z transform of yn plus 2, okay, plus Z transform of yn is equal to 2 times Z transform of 1. Okay, now here you can make use of what? Shifting property. So if you want, I can rewrite that shifting property like using Z transform of f of n plus k, which is equal to z power k f of z minus f0 minus f1 by z minus f2 by z square minus and so on. Okay, and the other notation, you know, Z transform of yn, I can write it as y of z. Okay, so continuing this and applying this, so what I will be getting, I will use z power k. What is k? K is 2. So this is z square into, what is z transform of y of n? That is y of z, right? Minus, now if it is a 2, take only 2 terms, okay, f0 and f1, right? So here I am taking f0 means here y0 minus y1 by z, okay. Now plus z transform of yn is y of z, and this is 2 times, what is z transform of 1? It is z upon z minus 1. Simple. Okay, so now you can use this given conditions. So you can write here, but y0 is equal to 0 and y1 is also equal to 0. So just apply here. So when you apply here, you will be getting z square y of z, this is 0, this is 0 by z, which is 0, plus y of z is equal to 2z upon z minus 1. Simple. Now you look here, I can both the terms are 0, so I can take y of z common and I will remain with z square plus 1, is it? Z square plus 1 into y of z is equal to, I have taken this y of z common, so coefficient is 1, coefficient is z square, is equal to 2z upon z minus 1. Okay, so continuing this further, I will write the last equation as y of z is equal to 2z upon z minus 1 into z square plus 1. Simple. Okay, now just look at here. So as you can see, we have y of z is equal to now this, okay, and here you can apply the partial fraction method and separate this, okay. So let us try to write it as, so let me do it here now. You can write it directly. So this can be written as 2z upon z minus 1 into z square plus 1. Or if you want, you can take this z to here and you can write it y of z by z and write like 2 upon this. Okay. Why I am doing this? Because I know in the every z inverse we need z upon something. So that's why I am preserving this z. Now writing this one as a by z minus 1 plus bz plus c upon z square plus 1. Okay. Now you can find out a. How we can find out a? Put z is equal to 1 in the left hand side. Okay. Removing this factor. So z is equal to 1, removing this factor, 2 upon 1 square plus 1, 2, 2 by 2, 1. So a is equal to 1. Okay. And what about bz plus c? We have to take LCM. So when you take the LCM, you'll be getting 0z square plus 0z plus 2 is equal to, take the LCM of this, so I will be getting az square. Az square plus a plus bz square plus cz minus bz minus c. So this is nothing but collecting the like terms. So this is a plus b z square, right? Then c minus b z plus a minus c. Okay. So here you can take any values to be like, I have a to be 1. Okay. So I can take from here. Let me write this. And here I can write a plus b is equal to 0. A is equal to 1. So b is equal to minus 1. Okay. Now c I have to find out. So a minus c is equal to constant term. So a minus c is equal to 2. This implies, what is it? This implies a is 1. Okay. A minus c is equal to 2. Okay. So a minus c, so a is 1 minus c is equal to 2. So this is going to be minus c is equal to 1. So c is equal to minus 1. So I am getting a, b, c, right? If you want, you can take this also. Again, you will be getting c is equal to minus 1. So now I can write this one as y of z upon z is equal to 2. This can be written as this. Therefore 2 upon z minus 1 into z square plus 1 is equal to, what is it? A is 1. So 1 upon z minus 1 plus, what is b? B is minus 1. So minus bz upon z square plus 1. C is also minus 1. So 1 upon z square plus 1. Okay. So when I substitute here, so y of z by z is equal to 1 upon z minus 1 minus b is 1. So this is z upon z square plus 1 minus 1 upon z square plus 1. Okay. Any doubt up to this? We have solved this partial fraction here. Okay. So now multiply this z to the right. So this is y of z upon z minus 1 minus z square upon z square plus 1 minus z upon z square plus 1. Is it okay up to this? Now you can take inverse z transform. Taking inverse z transform, taking inverse z transform on both sides, we get, so what is it? Z inverse of y of z is equal to z inverse of z upon z minus 1 minus, this is z inverse of z square upon z square plus 1 minus z inverse of z upon z square plus 1. Simple. Now what is z inverse of yz? That is yn, okay, is equal to, this is inverse z transform of 1, or you can write 1 to the power n or 1 and the same thing, minus z inverse of this is cos n pi by 2, z inverse of, right? So this is cos n pi by 2, and this is z inverse of sin n pi by 2, right? So sin n pi by 2. So this is the solution of the given difference equation, okay? And this is what we have in this learning video. So I hope the things that I have been discussed here is clear to you. So thank you for watching and enjoy learning mathematics. Thank you.